Ideal partner and ideal gas follow the same law. You have the concept, you know the theory. Deep down, you also know that no gas is ideal. Good day, Batang IS! In today's lesson, we are going to learn more about the ideal gas law. I am Mrs. Karen Rose Baez, and let me present to you the last topic prepared by Mrs. Minerva M. Ramos. Ideal gas is a gas that conforms in physical behavior to a particular idealized relation between pressure, volume, and temperature called the ideal gas law. Aside from pressure, volume, and temperature, moles may also be combined to the three properties of gases to establish the relationship among the four variables affecting the behavior of gases. Boyle's, Charles, Gay-Lussac's, and Avogadro's laws, when combined, constitute the ideal gas law or ideal gas equation. The ideal gas law is based on the experimental measurements of the physical properties of gases: temperature, pressure, volume, and number of moles. Ideal gas equation may be expressed as P times V equals N times R times T, where P is pressure measured in atmosphere, V is volume measured in liter, T is temperature measured in Kelvin, N is the number of moles, and R is the ideal gas constant. This law tells that the volume of a gas varies directly with the number of moles and absolute temperature, and inversely proportional with pressure. The commonly used value for R is equal to 0.0821 liters times atmosphere per mole times Kelvin. The value of R is computed from the following. R is equal to P times V all over N times T. R is equal to 1 atmosphere times 22.4 liters all over 1 mole times 273 Kelvin. And that is equal to 0.0821 liter times atmosphere per mole times Kelvin. Since P times V is equal to N times R times T, we can derive the following formula. In solving for the pressure, we use the formula P is equal to N times R times T all over V. In solving for the volume, we use the formula V is equal to N times R times T all over P. In solving for the temperature, we use the formula T is equal to P times V all over N times R. And in solving for the number of molecules, we use the formula N is equal to P times V all over R times T. Since we already know the different formula that we can use, let us apply ideal gas law in the following problems. Sample problem number 1. What is the volume that 1.9685 mole of iodine will occupy under these conditions? The temperature is 300 degrees Celsius. The pressure is 740 millimeters of mercury. Now these are the given. The amount of gas, or the N, is 1.9685 mole of iodine. The temperature is 300 degrees Celsius. The pressure is 740 millimeters of mercury. And the gas constant is 0.0821 liters times atmosphere per mole times Kelvin. If the ideal gas constant that we are going to use is R is equal to 0.0821 liters times atmosphere per mole times Kelvin, then you must convert 740 millimeters of mercury to atm. And you must convert the 300 degrees Celsius to Kelvin. 740 millimeters of mercury is equivalent to 0.9737 atmosphere, and 300 degrees Celsius is equivalent to 573.15 Kelvin. So these are the given. N is equal to 1.9685 mole, T is equal to 573.15 Kelvin, P is equal to 0.9737 atmosphere, R is equal to 0.0821 liters times atmosphere per mole times Kelvin. And we're looking for the volume. So to solve for the volume, we use the formula V is equal to N times R times T all over P. So that is equal to 1.9685 mole times 0.0821 liters times atmosphere per mole times Kelvin times 573 Kelvin all over 0.9737 atmosphere. So we are going to cancel the units mole, atmosphere, and Kelvin. We are going to multiply 1.9685 to 0.0821 and 573, and then divide the answer by 0.9737, and the answer is 95.1 liters. The volume is equal to 95.1 liters. Sample problem number 2. A sample of helium occupies 10 liters of space at STP. How many moles of helium are present? So these are the information. The STP is the standard temperature and pressure. The standard temperature is 273.15 Kelvin, and the standard pressure is 1 atmosphere. Volume is 10 liters. So we are looking for the amount of gas in mole. To solve for the value of N, we use the formula N is equal to P times V all over R times T. And that is equal to 1 atmosphere times 10 liters all over 0.0821 liters times atmosphere per mole times Kelvin times 273.15 Kelvin. So we are going to cancel the unit atmosphere, liter, and Kelvin. So the answer is 0.45 mole of helium. Sample problem number 3. At what temperature will a 1 gram sample of neon gas exert a pressure of 500 torr in a 5-liter container? Since the given amount of gas is in gram, we need to convert it into mole. So 1 gram of neon gas times 1 mole over 20.18 grams. So we need to cancel the unit gram, multiply 1 gram to 1 mole, and divide it by 20.18 grams. And the answer is 0.04955 mole. And because the pressure is given in torr, we need to convert it into atmosphere. So 500 torr times 1 atmosphere divided by 760 torr. We need to cancel the unit torr and multiply 500 to 1 atmosphere and divide the answer by 760. So the answer is 0.6579 atmosphere. To solve for the temperature, we use the formula T is equal to P times V all over N times R. And that is equivalent to 0.6579 atmosphere times 5 liters all over 0.04955 mole times 0.0821 liters times atmosphere per mole times Kelvin. So we are going to cancel the units atmosphere, liters, and mole. And the final answer is 808.62 Kelvin. The temperature is 808.62 Kelvin. Thank you for your time and effort of watching the videos, solving the sample problems with me, and patiently answering the practice exercises or the formative tests. I really appreciate the effort. Again, thank you very much and congratulations, grade 10. See you when I see you. God bless.